So we're going to go over graphing quadratics that are in vertex form. The vertex form is if we have y equals a times the quantity x minus h squared plus k. This form tells us several things about the quadratic. First, we look at the a value and whether that's positive or negative. If a is positive, that means that our parabola opens up, or using the vocabulary from a couple days ago, down, or concave up. If a is a negative number, our parabola opens down. A also tells us two other things. Depending on the size of A, that'll let us know if our quadratic or the parabola is a wide parabola or a narrow parabola. So the sign of A tells us whether the parabola opens up or down. It's a size of A that tells us if the parabola is wide or narrow. We don't worry about the sign in terms of wide or narrow because the sign tells us up or down. But if that a value has an absolute value that's larger than 1, then we have a narrow parabola. And the bigger a is, the skinnier or the more narrow the parabola gets. If a is a number less than 1, then we have a wide parabola. And the smaller a is, the wider the parabola gets. So a tells us whether the parabola opens up or down, and if it's wide or narrow. The other piece we get from vertex form is the vertex itself, and that's where the h and the k come in. So it's just a matter of looking at the equation, and whatever number's in the h position is the x part of your vertex. Whatever number's in the k position is the k part or the y part of your vertex. So simply pulling those numbers out gives us the vertex. So we're going to go through a couple examples and show you everything that we're looking for when we graph a quadratic. So if we have y equals 2 times the quantity x minus 2 squared plus 3, we know that since this a value is a positive number, the parabola is going to open up. We also know since a is a number that's greater than 1, the parabola is going to be skinny. One thing I did not mention over here, we talked about a being greater than 1 or a being less than 1. If a is 1 itself, then we just have a normal or a standard parabola. So it's not going to be any wider than normal, not going to be any narrower than normal. So that's, again, just looking at the a value, we know that the parabola is going to open up, and it's also going to be skinny. Use a different color here. Then from the numbers in the h and the k position, we know a vertex is going to have an x coordinate of 2 and a k coordinate of -3. One thing to be careful of here, our standard for vertex form is x minus h. So since we have x minus 2, the h and the 2 are the same. That's why our vertex has the x coordinate of 2. The easiest, quickest way is just to do the opposite of what you see inside the parentheses. You see minus, you think negative, it's actually going to be a positive 2. You see a plus, you would think positive, it's actually going to be a negative 2. So just do the opposite of what you see in parentheses. Outside of the parentheses with the k, just do what you would see. So positive 3 gives you positive 3, negative 3 gives you negative 3. Then all parabolas are symmetric. They have what's called, if you remember from your vocabulary from Monday, an axis of symmetry. And that axis of symmetry always goes through the vertex. So if a vertex has coordinates of h, comma, k, then our axis of symmetry is that vertical line, x equals h. So the easiest way to do the axis of symmetry is to simply put x equals, and then whatever your h value is, in this case 2. Again, that's all just from the h and the k. This is a little bit different in terms of the order of what we're going to do. So usually we'll save the x-intercepts for last. Next thing we'll do is find the y-intercept. Now if you think about graphing in Algebra 1, every time the graph crossed the y-axis, you had a y-intercept, those points were always 0, something y value. So x is 0, y is something else. So we can find the y-intercept simply by letting x be 0 and evaluating. So if x is 0, we have y equals 2 times 0 minus 2 squared minus 3. So 0 minus 2 is negative 2. Squared is 4 times 2 gives us 8. Minus 3 gives us 5. So when x is 0, y is going to be equal to 5. At this point, we're going to go and graph everything that we have so far. And that'll lead us to the symmetric point or the point of symmetry and also our x-intercepts. So we know the vertex is at 2, comma, negative 3. There. We know the parabola is going to open up. We know that it's an axis of symmetry of x equals 2. So we're going to put that vertical line x equals 2 in there. I'm going to use a different color just so it shows up better. Go with yellow. We also have a y-intercept of 0, comma 5. So we're going to plot 0, comma 5. Now the point of symmetry is going to be that point on the other side of our parabola. So again, with the symmetry, we know if there's a point here, there's got to be a matching point across the axis of symmetry. And again, because it's symmetric, these two distances are going to be the same. So if we know our vertex is at 2, comma, negative 3, I don't like yellow, it's not very clear. We'll go purple. If we're at 2, comma, negative 3 for our vertex, and our y-intercept is at 0, comma 5, we know that there's got to be a point 2 units away from the axis of symmetry on the other side. So just finding that mirror image point. However far you are from the x-axis or from the axis of symmetry, whatever this distance is, this distance has to be the same. So in our example, we went 2 units to the left. So if we go 2 units to the right, then we have another point on the parabola. And because we were at x equals 2, we went 2 units to the right. Now our x value is 4. We still have the same y value to keep the point symmetric at 4, comma 5. That's going to be our point of symmetry. The last thing we're going to do is the x-intercepts. And we save them for last because they're the hardest to do. Plus, we can save ourselves some work by looking at the graph to see if we do or don't have x-intercepts. Now, in this case, the parabola is going to open up and it's going to cross the x-axis. So we do have x-intercepts, but we can save ourselves some work sometimes, because if the vertex was above the x-axis and the parabola opened up, there would be no x-intercepts, and we can save ourselves some work by not trying to find something that doesn't exist. Or if the vertex was below the x-axis and the parabola opened down, there'd also be no x-intercepts. In the third case, if a vertex was on the x-axis, whether the parabola opened up or down, then our x-intercepts would simply be the vertex. So if one of these three cases exists, then we can simply look at the graph and determine if we have x-intercepts or not. If it's not one of these three cases, then we have a little bit of work to do. So just like we know y-intercepts happen when x value is 0, x-intercepts happen when the y value is 0. So we're going to find the y-intercepts, or the x-intercepts, I'm sorry, by letting y be 0. We're going to have something, comma 0. So if y is equal to 0, we have 0 equals 2 times x minus 2, that quantity squared, minus 3. You have a couple different options from here. You could expand this, put it into standard form, get 0 equals, and trust me on this, you'll have 2x squared minus 8x plus 5. And you could use a quadratic formula and solve using the quadratic formula. And it's certainly something you can do. Again, you would just take the x minus 2, that quantity squared, FOIL it, distribute the 2, combine your like terms, you would end up with this. If it's in the vertex form, what you can do that makes this a little bit easier is solve by getting that squared expression all by itself. We'll add 3 to both sides. We'll divide both sides by 2. And then we'll take the square root of both sides. If we put the square root in, we need plus or minus. Then add 2 to both sides. We have 2 plus or minus the square root of 3 halves is equal to x. And if we rationalize that radical, we have 2 plus or minus square root of 2, multiply top and bottom by root 2. We have 2 plus or minus the square root of 6 over 2. And if we want to find out those decimal approximations, we can plug them in the calculator. And that gives us an idea of where to plot those x coordinates. And then we connect those points with a U-shaped curve. We have a pretty good sketch of our parabola. So x-intercepts, one of them is at 2 plus root 6 over, well, root 6 over 2. Another one is 2 minus the square of 6 over 2. My time's just almost up with this free trial screencast-o-matic, so I'll be back in just a second to go over this second example.